Hello all, welcome to the next tutorial of Core Java. In this we are going to discuss about very important part of Java, which is JDK, JVM and JRE. At the time of installation we have talked about it a little bit, but now we are going to discuss about these three entities in detail, namely JDK, which stands for Java Development Kit, JVM, which is Java Virtual Machine, and JRE, which is Java Runtime Environment. So first, let's get started with what is JDK. As I have already mentioned, JDK stands for Java Development Kit. What is provided by Java Development Kit, or why we need Java Development Kit, is whenever I need to develop any Java application on my system, I must have this Java Development Kit available. So this Java Development Kit is going to provide the environment for Java application development. Now this JDK is physically present on your system. It physically exists. What is meaning of it? Whenever you are installing Java on your system, you can see a folder named as JDK, which has got this required files and whatever predefined environment is there for Java application development is available in that folder. This JDK contains a private Java virtual machine and other resources such as interpreter or loader for the Java file, Java compiler for compilation of source code, then archiver. So if you want to convert your application or represent your application in a jar file, so jar stands for Java archive. A documentation generation, so if you want to generate Java doc for your application, so that which entity does what functionality will be clear to the developer who is referring to that particular code, that these all things are available through JDK. The JDK implementation is available in three platforms. One is Standard Edition, then Enterprise Edition, and Micro Edition, where Standard Edition allows us to develop desktop applications. Enterprise Edition has got environment for developing web-based or enterprise-based Java applications, and Micro Edition is used for developing software for various devices like a washing machine or microwave. So when these machines require some Java software development, this edition is utilized. This is the structure of JDK, where JDK consists of JRE, JVM, also certain set of libraries. JDK has development tools like Java C, which is Java compiler, and Java, which is Java executor. Code execution will be done using Java. Next is JRE. JRE stands for Java Runtime Environment. So whenever we have already developed any application, when we need to interpret and execute the code, then this JRE is helpful. So JRE, which stands for Java Runtime Environment, provides the environment for the execution of the code. JRE is implementation of JVM. Now, whenever I am installing JDK, JRE automatically gets installed, and JRE is implementation of JVM. So JVM is also available on our system. So JRE contains a set of libraries plus some other files which JVM will use for execution of the Java application. So first step is I'm going to create Java application, a .java file, for which JDK is going to help me. Then that will be compiled. Again, JDK will have that compiler. So compilation will be done. After successful compilation, this compiled code .class file will be given to JVM, and JVM will make use of JRE for execution of the application. This is the internal structure of JRE, which contains JVM and set of other libraries which are required for execution of applications, and other files, where other files can be supporting files which are required to have execution of the application. One more point to mention is JRE is also physically exist. So whenever you are installing JDK, we have seen that two folders are created. One is JDK folder, another is JRE folder. So both JDK and JRE has physical existence on your system. Next is JVM, which stands for Java Virtual Machine. So it is a machine, means it is going to perform certain operation. It is a software, and it is termed as virtual because there is no physical existence of this JVM. So like JDK or JRE, you will not be able to see any folder created as JVM, but it is already available inside JRE for you. So, but it is a virtual one. This JVM provides a runtime environment in which Java bytecode is being executed. So this is what we have seen. .java file given to compiler, .class file. .class file is provided to JVM, and JVM is responsible for interpretation and execution of the .class files. In addition to this, JVM can also run the programs which are written in other language and compiled to Java bytecode. Now, what is meaning of this is Java allows us to add some native code in our Java application. Native code is the code which is written in some other language and embedded into Java application. So to execute such applications, JVM helps for execution of that application. Now, what are the tasks of JVM? Is it is going to load the bytecode, verification of bytecode. Now, what is done in verification of bytecode is it checks that whatever bytecode I have loaded, that bytecode is not a threat to existing operating system. Because it should not happen that whenever we are trying to execute any Java application, there are some issues related to operating system. The system gets crashed. This must not happen. So for any code, there is verification is done, and then only that code will get interpreted. So that bytecode is being executed into operating system specific instructions and given to the runtime environment, and execution of the application of that .class file is performed by JVM. And for this execution, providing the runtime environment is the task of JVM. This particular diagram talks about the architecture of JVM, where in this architecture, let's see what all blocks are there and what is meaning of this. So first of all, class loader, as name suggests, it is going to load a class that is nothing but .class file. So whichever Java application we want to execute, that .class file will be loaded by class loader. Then there is a class or method area. So this class area stores the class structures such as runtime constant pool, field, and method data, and the code for the method. So in a class, whatever elements we have declared, all those will be stored in this class area. Then there is one more memory, which is heap. So whatever objects we are going to create at runtime, those objects will be stored in this heap area. Stack is going to hold the local variables, partial results of any operation, and it also holds the control over method invocation and whatever values are being written by any function execution. Then we have PC register, which stands for program counter register. It contains the address of Java virtual machine, which is being currently executed. Then we have native method stack. So this native method stack contains all native methods which are there in the application. So what is this native method call? Is, as I have already mentioned, or we discussed about some native code which is embedded into Java application, right? So that native code will be available in this native method stack. Then we have execution engine. This execution engine contains various elements like Java, a virtual processor, which is interpreter. So this interpreter is going to read the bytecode from that .class file and convert it into operating system specific instructions. This execution engine also holds just-in-time compiler, which is also termed as JIT. Now, what is the use of this JIT? Is basically it is used for improving the performance of application. Now, what JIT does is JIT compiles the part of bytecode which has got similar functionality, and this compilation is done at the same time so that the time which is required to compile each and every code separately is reduced, right? So basically compiler is nothing but the translator over here. So whenever .class file I have provided, so whatever is the common code, or we can say similar code is available, that is translated at once simultaneously, so that this execution is not performed sequentially, which is one by one. Then there is Java native interface. This is a framework which provides actually the interface when we need any communication with the application written in any other language which will be other than Java. So if I want some integration from Java application, so my basic application is in Java and I want to communicate with some other application, and that application is developed in some language which is other than Java. So that facility is provided by native method interface. So this is overview of internal structure or architecture of JVM. So in this session, we discussed about JDK, which is Java Development Kit, JRE, which is Java Runtime Environment, and JVM, which is Java Virtual Machine. We have already completed the installation of Java on our systems. So all these three things, JDK, JRE, and JVM, are already available on our systems. So we are ready to now develop Java applications and execute those applications, which we will be covering in forthcoming sessions. Thank you.